Here we have an example where they're asking us to find dy dx. That's just them saying find the derivative. Remember dy dx, that works the same as f prime of x and y prime of this given equation over here. And so the weirdness about this is for the first time ever as you get into this type of problem, you're going to start seeing that you have x's and y's sort of commingling throughout your entire equation. Up to this point in your life, you're used to seeing things where it's like y's on one side and you got a bunch of stuff on the other. It might be a bunch of crazy stuff, but it's all y equals blah, blah, blah. Here now, you know that you've got to sort of apply a different method because you've got these x's and y's sort of commingling. And that's where we run into this process of what's called implicit differentiation. We still need to find the derivative of this equation, but we have to do it slightly different here. So we take our equation, and what we're going to do right now is we are going to wrap that equation in a set of parentheses, and you are going to dx this entire equation. D over dx. The way you'll know what the bottom should be here is it's always going to match with whatever the derivative is. So if your letters change, if all of a sudden you're talking dA, dB on a problem, you would want to dB everybody. So here they're talking dy dx, so we're going to dx this entire equation. When I do implicit differentiation, I have a little saying I use, and my little saying is every time I take a derivative, I get extra stuff. And what that stuff is going to look like is sort of envision there being this little dotted box behind that D on top. And you're going to fill that box in with the letter of whatever you took the derivative of. So what that process is going to look like is we'll come through and we're going to ddx everything. So we take the derivative of x cubed like we normally would. That would be 3x squared. You took the derivative of an x, and so you were going to get a dx over dx. So we filled that little box in with an x because we took the derivative of an x. Keep moving down the road here. We ddx y squared, again, take the derivative like you normally would. That would be 2y. And then we get our extra stuff. We took the derivative of a y, so we're going to get a dy dx, filling that box in with a y. Then we're going to get equals, and we come down here and we're taking the derivative of this stuff. So what you notice is now instead of things being added and subtracted, you actually have x's and y's being multiplied. So chain rule, product rule, quotient rule, all of our derivative rules still apply. When we're talking about two things being multiplied, we know that what we need to do in that situation is apply the product rule. And so my product rule saying my product rule recipe goes f and then g prime plus g and then f prime. I label one of my chunks the f piece. I label the other chunk the g piece. And then I use those chunks to fill in my product rule. So it's g prime is when I'm taking the derivative of g, and f prime is when I'm taking the derivative of f. And it's only in those two moments right there that you're taking a derivative and you get your extra stuff. So we follow the rule. The rule says first go grab f. So we just grab the f piece. That's going to be x to the fifth. Then it says go grab g prime, so the derivative of the g piece. So we look at the g piece. The derivative of y to the fourth would be 4y cubed. We took a derivative, we get extra stuff. We took the derivative of a y, so we get a dy dx. Then we get a plus from our rule. It says go grab the g piece, so we go grab the g piece. And then the last piece says go grab f prime, so the derivative of our f piece. That's going to be 5x to the fourth. Took the derivative of an x, that's when we took our derivative, so we're going to get a dx. I'm squeezing it in there. Okay? So that is our entire derivative right now. Looking back, now the thing is just a big algebra problem. We are trying to, again, find dy dx. And so that's going to be our mission, is to solve this equation to get dy dx by itself. The first thing I do before I start running that algebra is I do what I call a cleanup step. You're going to work your way through this and just kind of put things back to proper order and cancel out where you can cancel out. So cleaning this thing up now, looking at that first term, I get 3x squared. And then dx over dx cancels itself out. It's kind of like having 5 divided by 5. Those things cancel out. That's just a 1. Moving on, we get plus 2y and then dy dx equals, you want to rearrange that stuff to make more sense in your brain. So it's always numbers and then alphabetical order. So 4x to the 5th, y to the 3rd, and then we've got a dy dx down there. And then at the end here, again, rearrange that to make more sense. That's going to be 5x to the 4th, y to the 4th, and then dx over dx, again, those cancel each other out right there. And so now we've got our simplified version. Algebra, algebra, algebra. We are trying to solve for dy dx. Whenever you run into a situation, and you often will when you're doing this type of problem, where you have multiple dy dx's and you're trying to get it to just be one, right? What we want at the end here is dy dx equals some answer. Our process for getting this down to a single dy dx is going to be to get everybody that has a dy dx on one side of the equals, and everything that doesn't have a dy dx needs to move to the other side. So I'm going to move everything with a dy dx to the left side of the equals, and I'm going to move everything without a dy dx to the right side. So I'm going to minus 3x squared, and then I'm going to move this piece that has the dy dx over to this left side. So minus 4x to the 5th, y cubed, dy dx. And then as we put that together, we cancel out the 3x squareds, and then we have 2y dy dx minus 4x to the 5th, y to the 3rd, dy dx. That equals, those chunks cancel, and then we have 5x to the 4th, y to the 4th minus 3x squared. The reason that we do all of that, why we get all of these things to have dy dx, is now that everybody on this side has a dy dx in it, I can factor a dy dx out of everybody. So I can pull a dy dx to the front. That's going to leave me with 2y minus 4x to the 5th, y cubed. And so now I've gone, and the rest of this stuff just stays the same. Now I've gone from multiple dy dx's down to just one dy dx over here. And so the final move is really just going to be a move of division. You're just going to divide both sides by 2y minus 4x to the 5th, y to the 3rd. Divide by 2y minus 4x to the 5th, y to the 3rd. And so then out of there, these cancel, leaving us with dy dx equals this equation. So 5x to the 4th minus 3x squared over 2y minus 4x to the 5th, y to the 3rd. So there is your derivative. Just like any other derivative, it's there and ready to be used to find the tangent line slope if you need it. Thanks for watching my video. If you liked it, please click that like button and subscribe. And also share it with your friends and anyone else you know who might be crying about an upcoming AP Calc test. You can find more videos from me, more sample AP Calc questions, and my complete AP Calc study guide over at my website, apcalcprep.com. Have a great one.